Well, welcome back. We're in the middle of chapter 4 and we're ready to roll on this one. We talked about exponents before, and as soon as I got my pen going here, there we go. Test out the pen, we're in good shape. Alright, so the exponentials look like this, and we're going to talk about logarithms. The important thing to remember is that logarithms are exponents. This should keep you out of a lot of trouble. Now remember, exponential functions and logarithmic functions are inverses. They're both one-to-one, of course. Now, here's our exponential function. If we swap the x's and the y's to get an inverse, this is what we get. X equals a to the y power. Here we go. X equals a to the y power. Now, notice that here's the exponent, here's the resultant number, and there's the base. Keep those three straight, because one of the things we need to do is to be able to convert between the logarithmic equations and the exponential equations. And I'll give you some examples. You should be an expert by the time we get to slide 57. So here we go. First of all, here's our base. Notice this positive number, and because 1 is a little bit silly, because a base of 1, nothing happens when you have an exponent there, or even when you take a root of a, if it happens to be a 1. So we're going to keep a. Now it can't be 0 either, remember? You have 0 to 1, not including 1, and then 1 to infinity. And it's the union of those two. You got this too. Now, depending on which area your base is from, you get a different looking logarithmic function or an exponential function. We'll get back to that again. So here's where I'm going to show you how to switch. If you've got something that has logarithms like this, switching to the exponential form is easy if you just remember two things. First of all, the base, I call it's in the basement, and also that logarithms are exponents. So when you take a logarithm, you're finding the exponent. This number over here is the exponent because logarithms are exponents, LRE. So if I take this statement right here, the first thing I do is start with the base. The base is 2, that's the number lowest. What's the exponent? Well, the exponent is a logarithm, so it's the number out here. And what's it equal to? Well, the number that we haven't used yet is the 8. There you go. And there's the answer. So next one, remember, go to the base first, write that down, put the exponent in because that's what logarithms are. They're exponents. And the 16 is the result. Now, could you do the rest? I suggest you pause it right here, see if you can do the rest. Try to keep your eyes away from looking on the right side. But it's a guide anyway. So we can look at these diagrams to see the relationship between these two. There's the logarithmic form. There's the exponent. Remember, the exponent's outside on the other side. This is a logarithm, and there's the base. It's in the basement. And this x is the result of using this base with this exponent. And there's the exponential form. These two statements are equivalent. And this gives you an idea of why it's called a one-to-one function. Okay, now how do we use that? Let's take this one. We've got a logarithm equals 3. Let's switch that to an exponential. Well, we start with what? We start with the base. So the base is x. Base is x. The exponent is 3. And the result of that is supposed to be 8 over 27. Now what is that? Well, if I want to find what x is, I'll have to take the cube root. If I take the cube root of the left side, there's the x. That's why we did it. And on the other side, we take the cube root of 8 over 27, and we can split those up to make it easy for ourselves. Cube root of 8 over the cube root of 27. And what's x? Oops, sorry. X is 2 over 3. There's our answer. All right? So there was our original equation. And that checks everything out. Next, let's try it with this one. Where do you start? Start with the base. 4. What's the exponent? Logarithms are exponents. Notice the cursor moving over here. So 5 halves is the exponent. No bit strange, but you're familiar with that. The top of the fraction is the power. The bottom is the index of the root. And what's that equal to? Look back over there. What's it say? And that's equal to our x. Now, there are two ways to do this. One way would be to take the 5th power of 4, and when we're done, take the square root, and that would give us x. However, whenever you see something like this, go the opposite direction. Make x the square root of 4 to the 5th power. Now, why is that easier? Well, try taking 4 to the 5th power. Do you recognize it? Probably not. 1024. And do you know what the square root of that is? Probably not. I think it's 1024. Whatever. It's a big number. What do we get over here, though? This makes it easy. If you take the square root first, that's a 2. Take that to the 5th power, and x is, and you can just keep track, 2, 4, 8, 16, 32 is x. And then we can check it. And if we want to check it, we can say x 32 to the 5th power equals 1024, and that's what we had for a while here. All right, remember, take the root first almost all the time. $32. All right, let's move on to the next one. We're going to solve this equation, and we're going to convert it to an exponential equation. Starts with a base. There's 49. What's the exponent? X. And we're supposed to get the cube root of 7. Now, how do we do that? 49 to the x. Well, let's do a little bit of changing around here. Notice the 49 and the 7. Interesting. 49 is 7 squared. So we can write 49 to the x as 7 squared to the x power. And on the right side, since this is a cube root, we can make 7 to the 1/3 power. We'll go one step further. We're going to make this 2x because a power to a power, you multiply the exponents. And here we've got 7 to the 1/3. Cursor's giving me trouble. Okay, now it's 1 to 1, so if we have the same base, we must have had the same exponent. So the 2x equals 1/3. And then divide by 2, x is 1/6. And then you can check it out. Okay, so for logarithmic functions, remember we're talking about positive numbers. So where's my cursor? There. We're talking about positive numbers. We're not going to bother with 1 because that would be silly to do that. And logarithms only make sense for numbers that are positive. So don't put anything here except for a positive number. Now, as I said earlier, exponentials and logarithmic functions are inverse of each other. They're one-to-one functions. Notice here, and on these slides, take note that we usually start by talking about the blue graph. So here we're talking about the blue graph. This is a log function. This one in particular with base 2 because it's simple. If we exchange the x's and the y's, because we can, to make a one-to-one function, our blue curve looks now like that red curve. And one thing I want you to take notice of is this line is right between them. If you grabbed a hold of this blue curve and flipped it around this y equals x, you'd get the red curve. And that's true of one-to-one functions. You notice also that for the logarithm, you've got an asymptote in this direction because it keeps getting closer to the y-axis without touching. And on the inverse function, it's asymptotic to the x-axis. X is for y's, remember? Exact opposite. So the domain of the exponential function, all real numbers. Range, all real numbers. So you can only find logarithms for positive numbers. There we go. Okay, here's our logarithmic function. And we're using, let's see, we're using a as the base. And in this case, a is going to be greater than 1. That's very important. And the graph looks like this. Notice that it goes through 1, 0. No matter what the base, it always goes through 1, 0. That's good to know. It also always goes, it also goes through A1, depending on what A is, of course. And it also goes through 1 over a, -1. These 3 points you can count on for a logarithmic function. And the asymptote. Remember, the asymptote is what the function is getting close to, or the graph of the function is getting close to. And there are your 3 points. You might want to temporarily memorize those, especially this one. So, 3 characteristics you want to remember with a logarithmic function right here. You're guaranteed 1 over a, -1, 1, 0, and a, 1. Second, you also want to remember this. If a is greater than 1 to the right, then what you've got is an increasing function, like this. If a is between 0 and 1, doesn't seem like it means much, but between 0 and 1, your graph looks like this instead. It's rotated around the y-axis. Flip it around. Number 3, the y-axis is a vertical asymptote. As you can see, well, I guess my picture isn't too good. It's getting closer and closer to the y-axis on this one. And on this one, it's getting close to the x-axis. Horizontal asymptote. The domain is 0 to infinity, and the range is all real numbers, because you can have negative exponents, right? And logarithms are exponents. So how do you graph this one? Let's take a look. Notice first what the base is. You always start with the base. The base is 1/2. What does that mean? That means that your graph is not going to look like this. It's going to be the opposite. So you get some points, because to get a nice graph, you need several points. Logarithms, as you've noticed already, are curves. So with any curve, you're going to need a number of points, usually 4 or 5 points, until you get a picture in your head of what it should look like when you smooth in the curve. And there you've got, first of all, you've got the exponential part, that's the blue one. And second of all, you've got this one. Notice right away, the base is at 3. That means it's going to be increasing. Pick some values for x, graph those, and you'll be in business. So pick some numbers, for example, for x that are going to work out evenly. Like 1 is easy because that'd be x to 0, 3 to 0. You want to pick 3, you want to pick 9 because they're powers of 3. You also might want some fractions. 1 over 3, which remember is 3 to the -1. And you also want to use 1 over 9, which is 3 to the -2, another integer. So if you want to write a logarithmic function, compare it with your exponential one. So how do you graph that? Give the domain and range. Well, remember, this has to be a positive number to be used as the argument in a logarithm. if that has to be a positive number, that means x minus 1 is positive. And if you solve that inequality, you've just found out what the domain is. All numbers greater than 1. The range, of course, will be all real numbers. I think I've got a duplication here. There we've got the graph. Remember, the picture for the straight log, the basic log, looks like this and goes through 1, 0. But the x minus 1, this is negative, so it moves the basic one. That's why I wanted you to know the basic functions. It moves it 1 unit to the right. And there we go. Now what does this do to it? Remember, in this one we had x minus 1 in the argument. In this one, it's outside the logarithm, changing each logarithm to 1 less. So what that does, it moves it down 1. So logarithm base 3 of x minus 1, you're moving cursors, playing tricks with me. You move the basic function 1 unit to the right. On this one, the 1 is outside, so you're going to move the basic formula, the basic graph of the formula, down by 1. Outside, you're going to move it up or down, inside the function, left or right. Domain and range, pretty easy. We don't have to worry about the -1. It's the x that's going to be used in the logarithmic function. So it's just x that must be positive. And what about the y's? As usual, all real numbers. Okay, how about this one? Oh, I went too far. We'll go back here. So what does this one look like? Remember what the basic one looks like. The logarithmic function looks like this, going through 1, 0. What does this do? It moves that function upward by 1. This moves the basic function backward by 2. Remember, this one moves it up or down, this one moves it left or right. And you can see the change there. The original one, up 1, and back 2. Now what can be fun about logarithms and exponents is you've got some basic properties. And using these properties, we can, well, with practice, you can have fun with these. But you have to get these down. Whether you call it memorizing or just practicing enough to where it becomes second nature, just get to that point. So, properties of logarithms. First property, don't call it number 1, I'm just saying it's the first one we're talking about here. The logarithm of a product, notice x and y are being multiplied, is the sum of the individual logarithms. Product, you can break it up into the sum of the two individual logarithms. So remember, xy log of x plus log of y. That's a little bit short, but you get the idea. Second, now remember, just for reference, log of xy, remember it's multiplication, equals log of x plus the log of y. That's when we're multiplying. Dividing, we're doing a bit of the opposite. We're dividing x by y. So for this one, you have the top one, the logarithm of that, minus the logarithm of the one on the bottom. Remember, for the product, you're adding it, logarithms. For the division, you're subtracting logarithms. And third, if you have an exponent, remember, this means you got r x's. Well, the simple way of looking at this is, if you've got an exponent over here, just slide it out front, and you get r times the log of x. Remember, that's a power. Now, this is something you don't have to memorize. That's totally up to you. But these are some simple ones, and these work for any a's at all, as long as they're positive, because that's the only way you can use them. Number one piece of trivia, the logarithm of a, logarithm of 1 base a, 0. Why? Because a to the 0, anything to the 0, is just 1. It's just writing it backwards, remember? And down here, a to the 1 equals a. So the logarithm of a to a is 1. Remember, what this is saying is, what exponent does a need to end up with that? Of course, just 1. Now, we get to play with this a little bit. First of all, notice what we're doing is multiplying. What does that mean we do with the exponents? Or the individual numbers? We add them. So this will be log, and don't forget the base, because it's not a typical base. Log of 7, that's the first of the multipliers, plus, because we're working with multiplication, log base 6, don't forget the base, and there's a 9. And there's how you split it. I'm going to go one step further, because notice that 3 squared is 9. So we can rewrite this as log base 6 of 7 plus, now this is log base 6 of 3 squared. So remember that third property? We can't do anything with this one. Log base 6 of 7 plus, slide that 2 out front, and we've got 2 log base 6 of 3. As you'll notice, the slides don't quite go that far, but I always like to give you a little bit of extra. So since you've got multiplication, you're adding exponents. See, they didn't do the exponent part, but I thought you'd like that. Now this one is talking about the division one. Remember, the fraction bar represents division. So you've got log base 9 of 15 divided by 7. So how's that go? Log of 9 of 15. Now you're dividing by 7, so it's minus its log base base 9 of 7. There you go. A little bit of practice, it'll become second nature. Next, we're going to rewrite this expression. How do you rewrite that expression? Well, remember, this part says square root. And remember also that 8 is 2 cubed. So what do you have? Well, this logarithm, if we use the 1/2 instead of the square root, it's just another way of saying square root. And then since that is an exponent, we'll slide it out front and use our power property. There we go. I could take it a little bit further. I don't think they're going to, so let's be smarter than them. So 1/2 log base 5. Now 8 is 2 cubed. What can we do with the exponent? Slide it out front. So I end up with 3 times 1/2, or 3/2, log base 5 of that 2. We're ahead of the slide makers. Doesn't that feel good? Okay, how about this one? How do you rewrite that one? First of all, write it log base A, m to what? Well, here's the power. So we have 2, and we have a root of 3, so it goes on the bottom. Then what? 2/3 is the power. So what are we going to do? We're going to bring that 2/3 out front. And there is our result. Okay, now if you got those down, come back to this one. Maybe hit a pause on this and come back to that. So one thing you can do is log base A, and you got m and q. It's going to be divided by what's in the denominator, so we're going to subtract logarithms, and you'll have log base A of p squared t to the 4th. This gets a little bit interesting. P to the 4th. T to the 4th, sorry. Okay, first part. We've got multiplication between the m and the n and the q. So we'll have log base A m plus log base A of n. Hesitate here. There, get my cursor back. Plus, because we're multiplying all of these, so we'll be adding the exponents. Now, second one, what do we have there? Well, let's divide and conquer. Let's work with this part right here and see what we've got. Well, after the minus sign, this logarithm is the logarithm of a product. So we'll have log base A of p squared plus, because it's multiplication, log base A of t to the 4th. Okay, we're getting close. Next, this 2 can come out up front. So log A m plus log base A of n plus log base A of q. Now, we're going to have a minus that log, but we're going to bring the 2 out front, so we'll have minus 2 log base A of p. Got that? This was a p squared. We brought the 2 out front. And this negative distributes across there, so I have minus here as well. And this power of 4 comes out front, so I have minus 4 log base A of t. And there you go, folks. That's the expansion. Let me erase some of these marks. Clear it up so you can see what's going on here. There we go. So you can see the wrap up as the slide person put it. And watch out for the signs. Don't accidentally bring that 4 out front, and don't put a minus sign right there. Okay, can you do this one? It's just taking it a little step further, or maybe in a different direction. So let's start with the fractional exponents first. What do we have? Log base b, and all this fraction is to the nth power, so we've got x cubed y to the 5th over z to the m, and because it's to the nth root, this will be to the 1 over n power. Now we've got power to a power. How do we work with that? Well, we can bring this 1 over n out front. So 1 over n log base b, and we've got x cubed on the top along with y to the 5th and z to the m power on the bottom. Now we've got division going on, so that means we're going to be subtracting exponents. So we'll go back here so we have some room. Oops. 1 over n. Now we're dividing these, so we'll have log of what's on top, x cubed. My cursor's acting up again. X cubed y to the 5th minus log, all these are base b, z to the m. And remember, this 1 over n times all of this. Now what's next? 1 over n. I'm going to use braces because this is getting a little bit long. Now since this is multiplication here, I'm going to add those logarithms, or add those exponents, and we'll have the logarithm of x cubed, but x cubed, wait, I can make that 3 log of x to the base b. That's this one right here. Now we're multiplying the x cubed times the y to the 5th. We'll do the same with that. You're multiplying, so you add the second logarithm, which will be, oops, sorry. You never saw that. We're going to bring that 5 out front like we did with the 3, and log y of base b. Now that's the first part. We got this, and we're subtracting the second part. Well, the second part also has an exponent, so you're going to bring the m out front, so you have minus m log of z. And we can pretty much wrap this up. So we've got, excuse me, we've got 1/2 out front of all of this. Or I did it again, 1 over n, because we've got the nth root of this whole thing. So we'll take 1 over n times each one of these 3 terms. So we'll end up with 3 over n log of x base b. 1 over n times 5 will be 5 over n log base b of y. And over here the m is out front. We're going to multiply that by 1 over n. Keep going the whole way through. So we'll have minus m over n log of z. And there we go. We've got the whole thing. And they're going to do it a little bit differently, which is fine. As long as you follow the rules, you're going to get to the end result the same as they will. Let's clear that slide so you can see these better. There you go. Okay, so here's the slide guy working. So he brought that 1 over n out front. And then split it up. You've got x cubed, y to the 5th, z to the m. And then bring those exponents out in front of the individual logs, 3, 5, and m. And then multiply through using the distributive property. And there's your final result. Feeling more comfortable? Okay, let's do a few more and then we'll call it a night. So we want to write this as a single logarithm. So what we're going to do is we're going to reverse ourselves. What we just did, we're going to do the opposite. This way, you'll know how to do it both ways, and you'll understand the first one's better. So let's take a look at this. We've got a logarithm plus a logarithm minus a logarithm. Pluses mean we're multiplying. Minus means we're dividing. So our big logarithm, and all these have to be the same base or we can't do this. Now we've got x plus 2. Because I'm adding the log of x, it's times x. I'm going to put it out here instead of out in the back. And we're dividing by the log of 2, so 2 goes there. And there is one logarithm with everything. Okay, how about this one? Maybe this one will be a little bit easier for you. Can you pause it and do it? First one. Remember what we did with exponents? We brought them out in front of the log. So we're going to bring it back in as an exponent. So we'll have log base A of m squared. We brought the 2 up there. And we've got minus, which means we're going to be dividing. And what are we going to do with the 3? We're going to bring it in here as n cubed. And there you go. And there's our final. Using those properties. Get the properties down, practice them, and then it becomes play. How about this one? Can you take it one step further? Well, let's see what they do. You're probably tired of my chicken scratching, so let's give you a short break here. Now notice here, the 1/2 is out front, so we're going to bring this in here as the exponent of m. We'll bring the 3/2 in as the exponent of 2n, so make sure you have 2n in parentheses. And over here, you have 1 here, so we can keep that okay. So, there's our start. Bring the exponents in. And then combine those because you've got multiplication and division. Put it all together, and there you have it. Notice that we had to split up these two. So we brought that 2 to 3/2 out front, and we have n to the 3/2, and all that works out. And there's your final answer, because you don't want to leave it as that 2 cubed, because you know what that is. everyone knows, well, not everyone knows what that is, but we do. Okay. One thing you have to remember, we were just talking about adding logarithms and subtracting logarithms. Adding logarithms means you're multiplying. Subtracting logarithms means you're dividing. But what you can't do is this. Let's use a base b. Let's suppose we have log x plus log y to the base b. This is not log base b of x plus y. No, don't do that. This would be x times y. So keep that in mind. Put it down in red, whatever you need. Now a little bit of calculator work just so you can get some of these results as approximations. And we're going to, this one is given to you. Now notice that this base 10, we haven't mentioned it here, but if it's a base 10, it's called a common logarithm, because we commonly use base 10 in our daily life. Common logarithm if base is 10. If you don't see anything, if you see something like this, log of 17, if there's no base showing, it's automatically a 10, which is also what you would get if you looked at a table of regular logarithms. So how do you work this one? Well, we don't have the logarithm of 4. What can we do? Well, this is what we can do. Logarithm of 10, and I could have left this 10 out. 4 is what? It's 2 squared. We can bring this 2 out front, this 2 out front. So we have 2 logarithm to base 10 of 2, and we already know what that is. So all we have to do is multiply 2 times 0.301, my cursor's acting funny, 3010, and we can get our answer. 0.6020 is the answer. You might check that with your calculator too, just for some practice with the calculator. The two things you're going to use most often are log base 10. Come on, cursor, stop that. Log base 10 and log. Now here you'll see that e again. We have a special way of writing the log if it's the base e, the Euler's number. We use ln to represent that. Logarithm of x, if we don't have any base here, it's automatically 10. We don't use the base for e, we just use a special symbol, ln, for the natural logarithm of x. Okay. How about this one? We're getting pretty close, aren't we? Well, how are 5 and 10 connected? How does 2 get in there? Well, here's how you can do it. Logarithm of 5 could be split up into logarithm of 10 divided by 2. How about that? And then what? Well, this is division, right? So we can make this the logarithm of 10 minus the logarithm of 2. And we know what this is. What about the logarithm of 10 to the base 10? Well, if these two are the same, it's just 1, because this to what power gives you 10, or 1. So it's 1 minus 0. A little bit of cursor trouble here. Big decimal point, right? 1 minus 3010. And there's our answer. Okay. Finishing up. Remember, our a has to be positive for us to take a logarithm. We don't bother with 1 because that would be silly. A couple of things to note. Note what the base here is. The base here is a, and the base on this logarithm is a. And what this part means is a to what power equals x. A to what power equals x. A equals x. Well, what are we doing? We're taking a to that power. So we'll get x. In other words, these two, the exponent and the logarithm, are inverses, so they sort of cancel each other out. Remember, they're inverses, so they undo each other. Taking the logarithm of the number and then using it as an exponent is just undoing it. And the second one that looks similar to that is if we take the logarithm of a to the x, base a. Remember what this means. Well, first of all, you can bring this x out front, so you could rewrite this real fast as logarithm of a to the base a, but if the base and this number are the same, it's just 1. So it's x times 1, and there you go. Whether you care to memorize that or work through it each time, that's totally up to you. Here are 3 fast examples. You got 7 to the log 7 of 10. These two undo each other, which means you end up with a 10 again. If you look at this function-wise, where's my cursor? There we go. If you're looking at this function-wise, you're starting with 10, you're taking the logarithm of it, and then you're taking that as a power of 7. So these two undo each other, and you end up with the original number, in this case, 10. Over here, bring that 3 out front. Logarithm of 5 to base 5 is 1. If this and this are the same, you just got a 1 for a logarithm. So you got 3 times 1, and there is your 3. So can you do this one? Logarithm and power cancel each other out, so you just get the k plus 1 back. So the sequence on this is you start with k plus 1, using it as a power, then you take the logarithm of it, they reverse each other, you end up with k plus 1 again. Well, you've made it through, and we're ready to call it quits for right now. Good luck with the exercise. Bring in your questions, and we'll get you straight so that you become an expert on exponents, and especially logarithms. Take care. Bye-bye.